CRB, continuous regenerative braking, refers to an innovative way to manage the kinetic energy of solid and rigid bodies. When it comes to electric vehicles, this means to recharge the batteries while traveling, using the kinetic energy of the vehicle itself. This system was inspired by operation systems in renewable energies. And for a better understanding, we will show a similarity between wind energy and this system applied to an electric car. The wind turbine, which has an electric motor generator installed in the nacelle, initially receives energy from the electric network to place the blades at a certain number of nominal RPM, for example 20. Before reaching a certain speed, for example 5 meters per second, the wind does not exert any influence on the blades because they rotate at a higher speed. It is when the wind speed increases that it puts pressure on the blades. They begin to collect its kinetic energy, transform it into electrical energy, and return it to the network. In this operation, there's a compelling force that moves a mass, the wind, and an element that stops that mass, the wind turbine. It's important to remember that the mass, the wind, that slows down the wind turbine does not start at rest, but from a permanent speed regime, 5 meters per second. Even if the wind speed increases, the nominal RPM of the blades will not vary and will continue at 20 RPM. Now, we will apply this procedure to an electric vehicle that weighs 1,500 kilograms. The vehicle is equipped with an asynchronous induction motor. Before starting the energy recovery, the vehicle must reach a permanent speed, for example 100 kilometers per hour. To make it similar to the wind power case, we'll install another motor in the vehicle which will act as a driving propelling force. This way, as in the wind power example, we have a driving force that moves a mass and an element that slows it down. With the vehicle at a permanent speed regime, 100 kilometers per hour, we'll execute an additional and constant push with the propulsion motor, resulting in an increase of speed of, for example, 30 kilometers per hour. Total, 130 kilometers per hour. This increase will not occur physically, as the generator will stop any external force that intends to modify its RPM or frequency. It will transform the kinetic energy plus the propelling energy from the motor that amounts to 30 kilometers per hour into electric energy that will be used to recharge the battery. For a 1,500 kilogram vehicle, the kinetic energy used, minus friction and electrical losses, is as follows. As we can see, the volume of kinetic energy used is important and is produced by the acceleration of the body and not by the deceleration, which is how it's currently done. The recharge will be constant while we travel. It is difficult to use this procedure when circulating through the city, as the necessary speed for a recharge is difficult to reach. We must use it when driving on open roads or highways, where we can reach a suitable and constant speed, which could be from 60 kilometers per hour.